Okay, we're going to start with some basics in genetics here. On the right-hand side, what you'll see are some of those vocabulary words that we're going to cover in the next few minutes. If you feel like this video is going too quickly, remember you can pause this and rewind it at any time. So I'm not necessarily going to have long pauses here. I'm going to expect that when you're writing something down, or if you need to hear something again, that you just pause it and or rewind it and listen to that segment again. Again, if you go through this whole lesson and have questions or really are unclear on something, then that's your prompt to certainly shoot me an email and ask about some of those things, or set up a time to chat and I can go through them or explain them in a different way. So we're going to start with some of these vocabulary words, and I think we're going to use an example here which I think will really help you guys to understand this. So we're going to start with the word traits. So traits are nothing more than the specific features of an organism. These are usually synonymous with phenotype. So you'll see both those terms are in your vocabulary list that you should have already copied down and put in your notebook, and be following through on those, putting down definitions and examples and clarifications, questions, things like that. So we're going to start here with an example of my sister and I. So my sister and I, we're the only two kids in the family. We both have blue eyes. My parents both have brown eyes. So what we want to do is see if we can figure out what the genes of my parents are, or what the genotype of my parents are. And whether they're the same genotypes or different or whatever, and how two people with brown eyes could end up having two kids both with blue eyes. So what we'll do here is we will use a Punnet square. So you'll see that these are Punnet squares. You may have seen these before. Some of you guys have messed around with these, maybe in elementary school. But we're going to use a Punnet square for this single trait, and this is what's called a monohybrid Punnet square. So we're just looking at mono, or one particular trait. We'll actually get into dihybrid later. So we're looking at one particular trait or genotype, which is eye color. So the things you have to know are that there are pairs of letters that go together. So for example, brown eyes is dominant to blue eyes, meaning that if the brown allele is ever present, it wins. Think of it like a bully. If it's ever present, it wins. And we always represent genotypes using the first letter of the word that represents the dominant gene. Now in this case, maybe a bad example, brown and blue both start with B. So you'll see some other examples where this is a little clearer, but here's what you have. So you have a capital B and you have a lowercase b. So each of these individual letters is an allele. Okay? The letters together make up a genotype. So each of the people in our family, my sister and I, my mom and dad, each have a particular genotype. Those genotypes are just pairs of letters, so we each have some combination. So the combination possibilities, and order doesn't matter, the combination possibilities are, we have capital B, we have capital B, lowercase b, and then we have lowercase b, lowercase b. Those are the only three combinations possible. Like I said, the order doesn't matter. You always put the capital before the lowercase if they're mixed or heterozygous like this. So you wouldn't want to say that an additional option would be lowercase b, capital B, because that's the same as this. And the other thing to always in this unit, really important, designate or specify capital versus lowercase. You can't just say BB, because look at all three of these. All three of these are BBs. You must say capital B, or capital B, lowercase b, or lowercase b, lowercase b. Otherwise, no one knows what you're talking about, and there are too many options. So, what we know is that if the capital B, since brown is dominant, if the capital B is ever present, it wins. Brown eyes prevail. That's what happens. Okay? So in this case, take a minute and think, what color eyes would result from this genotype? These two alleles, capital B, would result in, yes, brown eyes. Capital B, lowercase b, still have the bully here, right? The dominant allele, capital B, lowercase b, results in brown eyes again. Aha, what about this case? You have recessive allele and recessive allele. So in this case, only in this case, could you end up with blue eyes. So let's think again about our example. Okay? So my parents, if they both have brown eyes, they could be capital B, or capital B, lowercase b. Okay? But they've got to, when they have kids, it has to be a possibility that they have lowercase b as one of the options. A Punnet square shows us probability. Okay? And so it'll basically show us out of 4 options what percentage of the time statistically could you get a certain genotype and resulting phenotype. So let's say we'll put one parent across the top and one parent across the side, and then it's just cross multiplying here. So let's say my dad is across the top and he is brown eyes like this, and my mom, so he would be what we call homozygous dominant. Homo is a prefix that means same. So in this case, you have the same, both are capital letters. So this would be homozygous dominant. Guess what this would be? This would be homozygous recessive. So if my mom were, maybe you've already guessed it already, now she has different, one uppercase and one lowercase. This is called heterozygous. Hetero means different. Okay? So we got her here, and then all you do is cross multiply. You're going to see, sorry, I'm writing with my mouse here. You're going to see here capital B, because we have this one here and this one here. You're going to have the same here. Okay, you're going to have here, you're going to have always capital first. So you're going to have capital B, lowercase b, and the same here, capital B, lowercase b. Well, in this situation, this scenario, it's impossible for them to have children with blue eyes because there are no homozygous recessive genotypes listed here. We've got homozygous dominant, heterozygous, and heterozygous. And so 100% of the time you will have kids with brown eyes if one parent is homozygous dominant and the other is heterozygous. Well, what's the other option? Because it really wouldn't matter if we took these two capital B's and put them on the side and put the capital and lowercase on top, you'd get the same answers, right? That's the nice thing about multiplication. What if both my parents were heterozygous? Okay. In this situation, you would have, start saying it, lots of big words. That's why we did vocab ahead of time in this unit. We have homozygous, remember, same capitals, they're both uppercase. Homozygous, and it's dominant because that's the brown allele. Here we have heterozygous. We're still looking at brown eyes, brown eyes. Here we have heterozygous. Aha, and here, 25% of the time, statistically, you're going to have blue eyes. And that's where my sister and I fell. Again, it's just like flipping a coin, though. You have to remember that with statistics. Flip a coin has two sides. It doesn't mean every other time you're going to get heads, tails, heads, tails. You may get 12 tails in a row. Okay? But if you did it 1,000 times, you would end up pretty darn close to 500 and 500. So this again is statistically, but it says that my parents still had a better chance of having offspring or kids with, we prefer the term kids, with brown eyes, but we both ended up having blue eyes. Okay, so again, looking at these vocab words on the side here, go back, rewind the video if you need to. Traits, we're looking at just individual specific features of organisms. Okay, this is usually synonymous with phenotype. Dominant refers to an allele that will always be expressed in the presence or within a genotype. So in this case, the dominant allele is capital B, which stands for brown. Again, maybe not the best example because brown and blue both start with B's, and you'll see this later. But again, anytime the capital B is present, since it's dominant, it will be expressed. Recessive is only expressed in the absence of a dominant allele. Right? So only if I have two recessive alleles together in a genotype. The genotype is the pair of alleles. The allele is the individual gene. Okay? So again, genotype is the pair of alleles. Phenotype is the outcome. So in this case, the genotype would be capital B, capital B. The phenotype would be brown eyes. Here, capital B, lowercase b. Phenotype, brown eyes. Here, lowercase b, phenotype, blue eyes. So phenotype is the physical characteristic that is expressed. Again, the allele, individual letter within the pair or the genotype. Heterozygous, we have heterozygous here, we have heterozygous here. Both these are homozygous. This is homozygous what? Yep, dominant. This is homozygous recessive. Okay. So again, heterozygous, homozygous should cover a bunch of your vocabulary here. Again, please feel free to rewind the lesson, watch it again, listen to different parts, try your own. You're gonna plenty of practice with Punnet squares, but think about these and you get plenty of practice, I promise, with phenotypes that both don't start with the same letter. Sorry about that. It was just a good example because this is actually true. But my sister and I both have blue eyes and my parents both have brown eyes. All right, hope this helps, guys.